Good afternoon, everyone. Thank you for joining us today for our webinar about uses and load capacities. My name is Julie Ledbetter. I'm the Sales and Marketing Coordinator at York Concepts. We are a full-service design-build firm specializing in vehicular and pedestrian bridges focused on longevity, style, and craftsmanship. We have over 7,000 bridges that can be seen in almost all 50 states, as well as the Caribbean islands, Central America, and Europe. We create innovative crossing solutions for any environment. Timber bridges are our passion, and we're very good at it. So before I introduce our speaker for today, I would like to point out some of the Zoom features that we'll be utilizing throughout the webinar to enhance your interactive experience. We'll be posting links to articles, projects, and upcoming webinars in the chat. There's also a poll question that we'd like to get your feedback on right now because we will be sharing the results in just a few minutes. You may type a question in the Q&A and we'll answer at the end of the presentation. Or if you'd like to participate in the discussion at the end of the webinar, you're welcome to raise your hand and we will unmute your mic so you can participate. But don't worry, there's no video. So if you're working at home and you're still in your PJs, we won't see you. I'm so pleased to introduce our speaker today, James York, President and founder of York Concepts. He's a 36-year entrepreneur in the construction industry, a commercial developer, and our timber bridge expert for today. Thank you for joining me today, James.
Sure, it's great to be here. Thanks, Julie.
And before we get into our discussion, let's look at the results of our poll question. The question is, what is the largest vehicle that YBC has designed a bridge for? And let's look at the results now, and here they are. Well, let's see. If you guessed the LR 1400 crawler crane at 248,000 pounds gross vehicular weight, you are correct. Looks like 35% of you did get that one right. But what you may not know is that we have designed bridges for every vehicle on this list. Yep, especially our logging truck. Looks like that came in second. That's actually a standard HS20 bridge that we build many of. So thank you for participating in the poll. So let's look at what our topics will be for today. So uses, the obvious question is it vehicular or pedestrian? But there are many other concerns that James will address when it comes to use. Then we must determine what type of vehicles will be crossing the bridge and what the traffic level is going to be for both vehicles and pedestrians. So the first question we want to ask is, what's the use? This is our free-span vehicular bridge at Atlantic Beach Country Club in Jacksonville, Florida. James, thank you again for coming. Can you tell us a little bit about what we're seeing in this picture?
Sure, and again, I'm happy to be here. It's always fun to chat about bridges. So this is a bridge that, excuse me one second here. This is a bridge that we designed and engineered for housing development and a golf course community. It's a main entrance to the development and sees quite a bit of traffic per day. As you can see in the photo, a semi truck is crossing the bridge. This bridge is 2 lanes and has capacity for an HS20 truck loading. The HS20 truck loading supports most semi trucks that drive on the highway. This bridge spans across the canal and utilizes engineered wooden glue laminated stringers to support the loading. Also note the attached bridge sections on the left, and the bridge supports pedestrian traffic. And on the right, that bridge supports golf cart and maintenance traffic and shows the multiple uses that can be accommodated with a vehicular bridge. This was fun to design this bridge because our client was interested in doing something very nice. So we incorporated some of the architectural features from some of the buildings into the bridge design. So when a client comes to us with a crossing need, we look at some general items to determine the type of bridge that would be best for them. First, what are they crossing? A wetlands, a lake, a stream, or a river, maybe a ravine, and maybe even a road. Will it be used for vehicular or pedestrian traffic or both? And then what type of vehicles may drive on it and what capacity is necessary? Also, what type of project it is can drive the type of bridge. Uh, all of these things would help us in our recommendation for them. So let's chat about where our vehicular bridges are used and what they're used for. We design and build our vehicular bridges in many different places. Private development such as multifamily, single family, commercial, or business parks is probably our primary focus. Typically in these situations, a 2-lane vehicular bridge is what is required. Maybe if it's in the front entrance, a 3 to 4 lane bridge may be necessary. There may also may be a situation where a bridge may be needed as an alternative entrance or maybe for maintenance vehicles, and this may only require a single lane bridge. Attached sister bridges to the vehicular bridge, as you saw in the previous bridge installation there, may be pedestrian, bicycle, golf cart, really any ancillary use. HS20 capacities are typical in developments, but sometimes an HL93 or HS25 may be required. Emergency access vehicles may require special vehicle sister loading to the HS truck, as some fire trucks require a higher capacity. Those would probably be very specific to the fire truck that would be going across the bridge. During construction in a development or project, construction vehicles may be necessary to cross the bridge. This requires specific design of the bridge to handle that construction equipment. And we'll talk about that more about that in a little bit. You also build in parks, greenways, on secondary roads, on government projects, and many other areas. And there can be any type of bridge from single lane, double lane, and up. Designing bridges for industrial parks, mining operations, or temporary construction use requires a specific vehicle design, as we previously mentioned. We also design and build bridges for private driveways for homeowners. Typically, those are single lane bridges and they vary in the capacity that they require. So let's look at the features of this project we have shown and what makes it an interesting bridge for discussion. This development serves a large office headquarters. The bridge has a high traffic count of about 5,000 cars per day, which is quite a few cars. The bridge has an HS20 capacity. This bridge is unique in that it's 3 lanes wide, or maybe 35 foot in total width. And interestingly, the center lane switches traffic direction depending on the time of the day. So in the morning, you have 2 lanes coming in and 1 lane out, and then it reverses in the evening for traffic flow the opposite direction. The bridge uses a hardwood wear deck. This is a layer above the structural deck, and this is a specially milled hardwood for anti-skid design. And for the volume of traffic, it should hold up very well in this environment. As you can see, there's an attached sidewalk, and obviously that provides pedestrian access as well. And then something I find unique on this application is the triple span design. and it actually has a trail that meanders underneath the bridge. So in regards to widths of vehicular bridges, we can build a bridge really to any width. Could be 3, 4, 5 lanes. We have done several applications with 2 separate double lane bridges going opposite directions in a development and using an earthen medium in the middle. So when our clients are planning a pedestrian bridge, again, we look at what is it crossing? And then we also look at what type of pedestrian crossing we're looking at. Pedestrian bridges can range widely in their use. Sometimes you may have a bridge that's going from point A to B and it has a few people crossing at a time. And then in some situations, you could actually have a spectator type environment where the bridge could be fully loaded, and that capacity should be taken into consideration when designing a pedestrian bridge. If a pedestrian bridge is on a trail setting, secondary traffic should be considered. Multiple uses in addition to pedestrian loadings can be maybe for golf carts, bicycles, emergency vehicles, maintenance vehicles, and such. So that should be taken into consideration. When I say sister, I mean if it's a pounds per square foot live load for pedestrians, then you would have an or for whatever vehicle loading or whatever else you're loading. Boardwalk complexes are something that brings entertainment value to the wetlands, and those should be designed with the appropriate capacity depending on the use. ADA compliance should be taken into consideration when designing a pedestrian bridge, both ramping requirements and additional grab rail requirements. Something else to consider when we're consulting on a pedestrian bridge with a client is aesthetics. It can drive the price when they're looking for something architecturally beautiful or something unique, which we love to design and build. So a super cool project in the slide there is the highlight some of my previous comments. This is the Cancer Survivors Park Boardwalk. This boardwalk meanders through the woods and expanded and a city trail in Greenville, and is an integral part of the Cancer Survivors nonprofit park. The bridge was a challenge to say the least. This bridge was built approximately 1,000 feet long, and it's through an existing wooded area and has a drop in elevation of about 50 feet from end to end. Some of the challenges on this bridge, just some interesting things on it, was we had to overcome those extreme grades in the design and construction, and also keep the boardwalk structure and ADA compliance. So that was something that was a challenge in design and then in the field also. Minimal clearing was allowed on this project. Just interesting that there was no trees allowed to be cut down over 3 inches in diameter. So there was some field adjustments that were required because of that on the layout. But that's not all. We also had to drill and drive our pilings from deck level. And sometimes we might have been 15 to 20 foot off the ground. So this was a tedious task to say the least. And but this project was a really good example of an environmentally friendly project that was performed also with maximum safety standards in place. A few additional notes about this installation. The capacity of this bridge is 100 PSF. Just note the people gathered on the deck in the photo. We incorporated both 4 0.5% slopes and 8% slopes with landings to achieve the drop and stay within ADA standards. It also incorporates an additional safety rail for handicap purposes. So one thing that we like to do at York is continue to partner with different clients through the years, and we continue to do that with Cancer Survivors Park today. And so what are some of the general considerations when it comes to load capacities for vehicular bridges? So based on the use and type of vehicles, we determine which load capacity will be necessary to accommodate the crossing needs. Bridge design must meet or exceed AASHTO standards, and capacities can range from an H5 truck capacity to an HL93 loading. So let's dive into bridge capacities. Please note the truck diagrams with the axle spacing and loading for the HS20 truck design and the HS25. If you notice, their footprint is the same. It's the gross vehicle weight and the axle capacity that changes. So on the HS20 truck, we have a 72,000 pound gross vehicle weight with the front axle at 8,000 pounds and the two rear axles at 32,000 pounds apiece. And then the HS25, you have a 10,000 front axle and 40,000 on each rear axle. So the footprint is the same. And the one thing to note here is the 14 feet minimum spread, and that keeps the loading a little bit further apart. The Mount Washington Resort in New Hampshire is in the photo on the right. We designed and built a free spanning 80-foot long bridge here. It's a 2-lane bridge that serves as the entrance to the facility. A little known fact about Mount Washington Resort is it's famous for hosting a UN meeting in 1944 where the World Bank was formed. So I'm sure many of you didn't know that, but that's pretty cool that we had the opportunity to build this bridge there. This bridge has an HS25 capacity. This is standard on a lot of the roads in New Hampshire. One interesting fact on the project that was cool for us is that our wooden York Bridge replaced an old concrete bridge. And I'm sure some of you have probably seen where an old timber bridge was replaced by concrete or steel. Well, this is a great example of a client having confidence in our 75-year bridge design. So we've discussed HS20, HS25 loadings. So let's chat on the difference with an HL93 loading. So in addition to the HS20 truck loading, the HL93 incorporates 640 pounds of uniform load per foot per lane. So if you take, for instance, a 50-foot long 2-lane bridge, then you're adding 64,000 pounds of capacity to the 72,000 pound semi truck. And that is the capacity that the bridge would have to be able to hold. Creates a much stronger bridge, but also keep in mind that drives the costs of the structure. This standard has started being adopted by some highways. Private developments typically do not require an HL93 loading. That'd be something on each individual development to look for. So this slide shows our Bridgehaven at Citrus Park project. This bridge was designed with a center span of 40 feet and several repetitive spans of 15 feet to the end of the floodplain. So the 40-foot took care of the creek boundaries, and then the 15-foot repetitive spans got us out of the floodplain. And the bridge design was a economical approach in lieu of an entire free span. This bridge joins two sections of a multifamily development. The development was a platted development, and the county DOT mandated that the bridge use the HL 93 capacity in case they would own it in the future. So this isn't typical. HS 20 is very typical for developments of all kinds and still used widely throughout today. And it just was a specific requirement on this project. This capacity was easily incorporated though by our design team, and many of the structural members, such as the stringers, increased in size compared to an HS20 design. Also, just a special note, the guide rails use glue laminated members for strength. As you can see, this bridge serves both pedestrians and vehicle traffic. So now some boring facts about H versus HS. So an H truck is really stands for a fixed body truck. So you've seen your typical FedEx or UPS truck or something along those lines. Whereas an HS truck is two connected bodies. So that's why sometimes you see driving down the highway a separate truck with no trailer on it. And then once the trailer goes on it, there's your HS. A standard H truck is comprised of two axles with the same 14-foot minimum axle spread as the HS design. So all the design trucks are with the 14-foot minimum axle. An HS truck is a standard hitch trailer axle configuration. The S represents a semi-trailer combination. So I'm sure you all wanted to know that, and now you do. Typically, lighter vehicles would be designed as H5, H10, H15, or H20. As you can see in the truck diagram, the rear axle takes 80% of the loading. And that's typical for the design of an H truck. On the right is a good example of a bridge installation where a lighter capacity was fitting. So this bridge capacity here is an H5. This bridge was built primarily for cars to be moved in a car dealership to an ancillary parking lot. Also, you can see the attached pedestrian loading, which is rated at 90 PSF. So this is really cool bridge. I love this bridge. I love the natural look of it, but this is a private homeowner's bridge and has an H10 truck capacity. As you can see, this bridge crosses a pond. It's comprised of 3 spans, again, using engineered glue laminated stringers to accommodate the spans. This bridge is a 12-foot wide single lane bridge and has daily use for automobiles, delivery trucks, and emergency vehicles. So there are certain times when a specialty load capacity is necessary. We kind of chatted on uses on that before. Let's discuss how we would accommodate this. Specialty loadings may be necessary, as we discussed before, for construction sites, mining sites, industrial. When we have this type of situation, we custom design the bridge according to the vehicular diagram, such as the two shown, which we have designed bridges for each of these. The vehicle diagrams of the lowboy crane vehicle is 248,000 pound gross vehicle weight and has a length of 120 feet. The second vehicle is a Volvo HAF truck that's 101,000 pounds and it has a length of 34 feet. So in designing the two bridges, or I'm sorry, designing the bridges for each of these two vehicles, um, the low boy crane vehicle is 128 feet long and barely fit on the bridge that it was going to be on. So, and the bridge was a repetitive span bridge. So by the time the vehicle is several axles further up, it's on another segment of the bridge supported by more vertical supports. The Volvo AF truck is a more compact design, 34 feet. Your two rear axles are very close together. They comprise of approximately 70,000 pounds of that 100,000 pound vehicle. And so you're going to have much more of a point loading there that has to be designed for. If you're looking at a free span structure, where you're spanning, say, 50 or 60 feet, you have to have that point load right on the center of the bridge. If you're designing for a repetitive span structure, same thing, but obviously your span is much less. And then as it goes further across the bridge, you have a new segment of supports that support it. So the next slide here, we have our Big Bend project. This is a facility for our local energy provider in Tampa. And this was a special situation where we custom designed and built for their particular vehicle that you can see in the diagram. This crane vehicle pictured as a Mercedes Tier 4 crane vehicle with a gross vehicle weight of 73 tons. Very compact, very much need to take into consideration that in the design. The bridge provides access for the vehicle to serve for the electric towers throughout their facility. I should say the bridges. We designed and built multiple bridges for the facility and have many more to build in the future. Actually, they're replacing all of their old bridges, both culverts and the other bridges, with our timber bridges. The client appreciates the environmentally friendly aspect of wooden bridges. And, I don't know if many of you know, but being that they're timber, they're a renewable resource. They also like the option of our bridge, and you can see in the one profile shot there, the openness of the creek flow, and they like that over the concrete culvert. And if you're interested, by the way, in checking out our webinar recording on culverts versus bridges, Seattle is going to link it to the chat if you'd like to take a look. So as we discussed earlier about considerations for pedestrian timber use, let's discuss how this translates to load capacity and what our standards are to help a client decide what they need. So 90 pounds per square foot is what we typically design to today. And that is AASHTO's current loading for standard for pedestrian bridges. Pedestrian bridges can be designed anywhere from 60 PSF to 100 PSF or higher. When I say PSF, pounds per square foot, we typically use the 90 as the standard. And then in some cases, like the Cancer Survivors Boardwalk, as you saw earlier, is designed at 100 pounds per square foot. Sister loadings may be used in a lot of cases. Sometimes it could be an H5 loading for maintenance traffic, or maybe large golf carts. It could be H10 for emergency vehicles. AASHTO standards require secondary uses in some applications depending on the widths. A way to get around that sometimes is putting a bollard at each end of the bridge. This can eliminate the need for that secondary use. The secondary use obviously would drive cost because if it's a standard pedestrian bridge and then you add the H10 loading to it, it can drive the cost because you have to increase the member sizing. One little note, our typical pedestrian bridge can handle the use of a or the loading of a two-person golf cart on a normal basis. But there's other considerations that would need to be taken into consideration there with curbing and type of guide rail and other things. So this is a project I love to talk about, the Waterworks Park in Tampa. Very cool park. Um, the bridge connects the Riverwalk in Tampa, and this is a great example of a highly used pedestrian bridge with sister uses. This bridge was designed for 80 PSF at the time. That was before the switch to 90 PSF, by the way. And then the sister loading is a 5-ton gross vehicle weight loading. So it has a variety of uses. Pedestrians obviously use it on a normal basis, bicycles, wheelchairs, and maintenance vehicles. Obviously, that's the 5-ton loading. Waterworks Park, just a little bit, if I can tell you a little bit of the history, it's very cool. This was historically was home to the public waterworks building, which the building is actually still there today. Now there's restaurant in it, and I don't know if there's something else there, but there's a nice restaurant there. The waterworks facility used to be a source for drinking water for the city of Tampa some years ago. And the source was a spring. So the waterway that our bridge crosses, that spring is there. And it's so cool if you ever go to the restaurant, the fish and all the plants, it's they really did a nice job of creating a very environmentally friendly atmosphere there. Note the removable bollards at each end of the bridge. So that controls maintenance travel. So on a normal basis, it's pedestrians, and then they can take the bollards off when they want to use it for maintenance equipment.
Great. I think we made it through all of the vehicular and the pedestrian uses. Thank you so much, James, for your time today. And so at the beginning, some of you may have been saying, I didn't know a timber bridge could do that. And now that you know, we would love to hear from you. If you have any projects where you're working on a culvert or a particular situation where you didn't know a timber bridge could be into play, please be sure to let us know and send us your questions, send us your scopes, and we'll be glad to look at them and see what we can do. We just